Good afternoon and welcome to today's Umuvity webinar. We have PTV Group expert Sean Fitzgerald and Econolite's Dustin DeVoe showcasing the integration of Econolite's EOS into PTV Vissim. Just as a reminder before we get started, this webinar will be recorded and sent in a follow-up email. Please feel free to enter your questions in the question box at any time throughout the presentation. And now I'll pass the mic to Dustin to begin the presentation.
Great, thank you. Hello everyone. Thank you for joining today. I'm Dustin DeVoe. I'm the Vice President of Innovation and Technology for Hardware Products at Econolite and Umuvity. And we are really excited today to share the latest development with the EOS controller software as we've now successfully integrated within Vissim. First I'll start off with an introduction to the EOS controller software. And I'll cover some of the success stories, and then I'll pass it over to Sean to go through a technical slide deck to introduce you to the workflows. All right, next slide, please. Thanks. Yeah, so EOS software is something that Econolite's been doing we've been doing traffic software for quite a while, really since the 70s, software has been written here. And now maybe some of you have been familiar with the ASE3 software within Vissim. So we're really excited to present to you the next generation of our traffic software. We saw some real needs in the market and knew that the best way forward was to develop a newer generation beyond the ASE3. And so I'll talk more about that today. But it was launched in 2020, and it's been growing very rapidly. We're very excited to say that we've hit some significant milestones. I'll talk about that in the next slide. But there's some really great capabilities within the software, some market needs that we needed to meet, and that were really the impetus for us to take on this aggressive product development and rewriting our controller software. And one of those key areas was connected vehicle, as well as priority control, and just having software that can adapt to changing functions, in particularly when it comes to safety. So I'll talk a bit about this as we progress through the presentation. So to give you a sense, there's 20,000 EOS deployments out there, and I think actually Illinois just is going blue here. They've just deployed some for some of their preemption railway sites. Some of these initial sites were actually transit related. There's quite a few that were connected vehicle related, like up in the New England area. So there's been a broad acceptance across the United States as well as Canada, and we're starting to get some more international deployments as well. So we're really excited with the progress we've made just in the last 4 years. So now I want to switch into some of those success stories. We have EOS in the city of Houston. The county around it is Harris County, and there are over 1,000 intersections that we've deployed EOS there. It was actually one of the first major projects we were awarded for EOS. Really happy to work with the city there, or with the county and the city. They had a vision for implementing a priority control system across all of their intersections for their emergency responders, as well as their eventually transit. But we started with the emergency responders. So they equipped their vehicles with radio devices to send position data or estimated time of arrivals. And so that information is then sent down to the EOS software through an in-cabinet radio box over the network to our EOS software. And then we can provide priority control across the county using up-to-date arrival times and routes. So it's been really successful there in Harris County. They also really have seen significant improvements in the efficiency of their roadways just with how quickly the EOS software is able to handle coordination. I'll talk a little bit more about those capabilities here in another slide. Um, and then the ability to put it on some of their existing equipment, and provide necessary performance data. So this was a good way to start off with EOS. And once again, it was just great working with Harris County to make and have all these successes and be able to get them up to date just in the matter of a year. Next one was a success we had in Charlotte, and that was also one of our very early ones. Also a very visionary customer. They do have transit and emergency vehicle active now in their intersections. There are over 900 intersections there that we've deployed. We've made We have some really significant improvements we've made to the emergency response time there, going from 3 minutes and 34 seconds to 3 minutes and 12 seconds. And as you all may know, that those are precious seconds and can save lives. So we're really happy that we were able to be a part of that solution, because it really does make a difference there for the well-being of people in Charlotte. And the other great aspect of our implementation there is that the priority control system was all done at the central. So we connected our central systems, Centrac software, to their CAD AVL system, so we knew routes and position data at a fairly regular update interval. And so our priority control system would then send the priority request directly down to the EOS software from their main server. And we're able to equip their whole city without having to install any additional equipment. They just installed the EOS software and their controllers, and had the Centrax software at the central processing and sending down those priority requests. This made for a very effective system that we're able to bring up very quickly. But the other aspect that was important to that was the ability to deploy updates, because as we went, we learned things, we made improvements, and we were able to remotely deploy that software without going through a flash interval, which is also really nice for the agency to get the latest updates and fixes and enhancements without having to go to flash. And so they can do that in the evenings or off-peak times. And so really great attribute of the EOS software. Last thing I want to note on Charlotte was the pedestrian safety. We did improve pedestrian crossings by adding some of the leaving pedestrian interval capabilities for their right turns, because they do deal with vehicle pedestrian conflicts quite a lot there. And so that some of the safety intervals I talked about earlier, that's an example of one where we get the pedestrian off the curb and out into the crossing before we signalize that any cars can take a permitted right turn. All right, for the next success story we had was also one of the earlier ones too, in Honolulu. This was through a partnership with the Department of Transportation in Hawaii and the University of Hawaii there in Honolulu, looking to develop up their connected vehicle test bed and research capabilities. So it was really a progressive project, and we made some significant improvements in the performance of their system, but just by updating with EOS and providing the Centrax software, the transit priority control, some connected vehicle equipment for communicating SPAT and DSRC and CV2X through CV2X as well as cloud, and then turned on our adaptive algorithms in Centrax. And as you can see, they've some significant performance increases with arrivals on green and arrivals on red, performance metrics improving significantly. So made a big impact there in Hawaii, and EOS was a part of that whole system improvement. So that gives you an idea of why EOS has been successful, and why it's we recommend you give it a try and have consider it for your next projects because the success continues. There's, as I mentioned, there's 20,000 of these intersections now, or more, and ever increasing. And there's a reason why EOS is very stable software. We've developed some really cool things in there, and now I'm going to talk about some of those. Um, Next slide, please, Sean. Starting off with those connected vehicle aspects, and this is one of the key aspects we needed when we looked at the redesign of our controller software, is that intersections today aren't like they were just even 10 years ago. The expectation for getting live performance data out of the system, for communicating additional protocols, those expectations are much higher. And so we needed a solution that could handle that. So EOS has built on what we had with ASE3 connected vehicle, because we pushed ASE3 connected vehicle signal phase and timing spat to be one of the best in the industry, and now we have additional capabilities with EOS that make it even better. And that is the addition of the J2735, the SAE J2735 messages, which you'll be able to get directly out of our Vissim SIL. Those messages are sent out, and they're pre-encoded so that an RSU would know to sign them, or roadside unit for a connected vehicle would then sign that and then forward that on to all the cars. So there's no additional processing needed at the RSU. That's a standard functionality defined for RSU compliance. And EOS can do that for SPAT map, as well as the signal service message or service request message for priority control, which it's actually a fairly new feature for us as of the last 6 months. So you can communicate signal time transitions to vehicles. You can communicate the geometry of the intersection, and now we can accept a priority requests and give those connected vehicles greens. So it's very powerful, and these are things we hope our users will consider experimenting with within Vissim. And we're extremely supportive of these efforts. We think the connected vehicle side is going to make a huge impact when it comes to roadway safety and efficiency, and we want to do as much as we can to help push that future forward as fast as we can. Last thing I wanted to mention was the cloud integration. So the EOS, back one there, Sean, sorry. The cloud integration of EOS is a key aspect. We can actually stream signal performance measures from EOS through a polling mechanism, but you can poll as frequently as you want and get the latest data. So that'll show up in your Centrax Mobility Cloud instance as soon as you need it, or other solutions that exist out there. That's also really beneficial when it comes to us processing optimization plans or full adaptive using the Centrax adaptive support. So cloud integration is a big part of EOS as well. All right, next slide. Thanks, Sean. The other key aspect I brought up earlier was the coordination side of EOS controller. This is an important legacy functionality of traffic controllers. We all speak in cycle offset and splits in North America. When it comes to coordination plans, the ability to adjust those times dynamically based on current roadway capacity is very important. And our goal was to be able to take adjustments instantly within EOS. And in order to approach this problem, we actually found inspiration through mechanical dial traffic controllers of old, and that you had a dial there, and you put electrical contacts within that dial to effectively create a path for the electrons to light up the signals. And so as it turned, it would rotate and those would deactivate and then the next contactor. And so that's how you would sequence lights. We took a similar approach when it came to our coordinator in that we have our fixed plan and cycle. And what we do is we slow down and speed up that cycle to change how long a cycle would take. So effectively creating your cycle length. And so all of the same functionality and programming exists there, but every time we make a change, it'll occur instantly within EOS, and because we've taken this approach, so it allows EOS to handle longer intervals, unexpected intervals, preemption intervals, plan changes, optimization on the fly. And that's a very powerful feature. Once our users really start understanding this, they see how impactful that can be. Even just changing plans, the plan change will occur quicker. As I mentioned, that was one thing that Harris County really liked about the product. So that's a key attribute. There's other functions that we've built in there. There's actually a adaptive split tuning capability right into the software, so you don't actually need to communicate to a server. It can be totally offline, and you can the EOS software will process local detector information at the stop bar and apply proven research from Purdue and Iowa State related to a green occupancy ratio and red occupancy ratio during that first 5 seconds, and balancing out the utilization of each split using those metrics. So the adaptive split capability is a very powerful one that our users are starting to take notice of and use more frequently when they can't be online and communicate to a central server. Also, some clever things you can do with logic and other programming options. And last thing I'll note is, as you can see there's kind of a green and yellow and red pie graph. That is a live graph we have within the EOS software. So when you log into our web interface, you'll see, and you're running in coordination, you'll see this graph. This will tell you exactly where you're at within your cycle and give you great insights into how the coordinator is working. So be sure to check that out as you get into this. Next slide, Sean. And this is my last point before I pass it over to Sean. I want to just kind of detail more about the priority capabilities within EOS. The AC3 software had TSP as well as SCP, which is a NTCIP term for signal control priority. EOS took that further, that signal control priority capability, and took it further, and we developed the priority request server within the controller itself. So what that means is we can receive 26 unique requests for priority, and the EOS software will queue those, process them in sequence, first come, first serve, as well as 10 different priority levels within that. So you can set up different classes of vehicles, such as emergency vehicle, snowplow, police, transit. You have those 10 different levels of classification that allow you that hierarchy of who gets the green when they're both approaching at the same time, and the also additional capabilities. So at the most aggressive capability or most aggressive level, like your emergency vehicle or situation, the SCP algorithms will actually do whatever they can to provide a green arrival for that vehicle. And so there's additional things it can do, like jumping phases within the sequence order, or just truncating. It will attempt to truncate if it needs to, and if it can't, then it'll selectively jump over that phase to ensure that green arrival for that emergency vehicle. But if you're talking about a transit vehicle at the higher, that's a lower number is the higher priority per the standard definitions. But at the lower class level, like a transit situation where you don't want to have any phase skipping, you can just program the extension and reduction times, and the EOS software will work within those parameters and adjust as accordingly, but only within those limits. So that gives you an idea of how the priority control system works. There's lots of things we could show you related to that topic. I just wanted to give you a preview of it before I pass it over to Sean to start showing you some of the exciting ways that this is now integrated within Vissim. I'll kick it over to you now, Sean.
Thank you, Dustin. Yeah, I see that you have a thank you and question slide, but we're kind of, since we're going to do this together, we'll move that just to the end for everybody kind of generally, I guess. Let me just switch to presentations real quick. Oh, that worked a lot easier than I thought. Can you see that all right? Anyone?
I see it,
Yes.
Sean.
Okay. Thank you very much. For those of you who don't know me, my name is Sean Fitzgerald, and I kind of work on the BDR side on the Vissim team, and so you kind of see me around. What we're going to discuss today is not exactly like, I guess, like a normal PTV talks of, wow, look at this crazy thing we've invented, or Levi giving his brilliant advice about how to make it better, but more or less, kind of show one of our new companion features and show both the theoretical implementation, the technical implementation, as well as the practical implementation. So this is all very new, and a lot of the customers who are using this don't share their data. So it'll be some here, let me switch to the next slide. That's what it's going to be anyway. So I'm going to introduce kind of how it's in Vissim and how it works, kind of introduce like how EOS works and how we put it in Vissim. And when I say how it works, the control panel that we call the web front panel is a Econolite thing. So Econolite customers will recognize the implementation and how it is in Vissim. And then I'll take a break to kind of show you around in Vissim itself. Come back and look at some of the data side of it, because as we all know, setting up data heavy signals, dynamic signals, detector based signals is data heavy. And since Econolite offers many things like syntax and different editors and stuff, data is often available first versus creating it from scratch. So a lot of good features there. Then we'll go back in the software and just kind of look at a few more things. And then if you have any interest in knowing more technically, you can talk to Levi or myself, and we can talk about specific details. Many of our customers, I'm sure many of you online right now, are much more knowledgeable about EOS than we are here at PTV. We have our friends at Econolite also here on the, not only at this webinar, but in the future to ask questions too. So the integration and just how it all works together in your system, in our system, in their system, we're open for future discussions and future questions. So if you have simple questions, we might be able to get to them at the end, but if you have a more detailed interest in knowing more, you should reach out to us and we can set something up for the future. With that, let's go through this. This presentation assumes that you were awake and paying attention for the last 25 minutes of exactly what EOS is. I'm not going to go about what it does, but EOS in Vissim is set up as what we call a quote unquote native system. And what I mean by native is you can see in that picture on the right in the drop down, and it's an option now there under the ASC3 that was already there. You now have the Econolite EOS. So no longer, it's not a signal type or a dynamic type that you have to program in through event-based scripting or Python or any kind of add-ons or DLLs. It's now part of the software. And the package DLL is part of the distribution itself. And in order to make it more like reality, I guess more of the digital twin software in the loop kind of, you use it, if you're a user in the field, you kind of understand what it is. The way that it has been integrated in Vissim is through the web front panel. Traditionally, through a lot of the signal types in Vissim, you would use some of the text editors or context editors, or even insert context files and then edit them in Vissim. Whereas the EOS system is designed more to intake EOS files and then interact with the web front panel, which is how you would do it in real life if you had an EOS system. So that's how that's designed to work, as well as there are some offline configure editor programs. So it's a bit different than some of our older quote unquote legacy systems within Vissim, but it's kind of an exciting way of like how SaaS integration allows different connections to be established from system to system. And like I said, it is a Vissim type and signals can be developed from scratch, but where the system really shines is the way that it's been integrated is allows for real signal timings and configuration files from Syntrax or from agencies or from outputs to be just kind of dropped in and ready to go. So I'll show a little bit that a little bit later in the presentation. So the first thing you'll notice are minor configuration differences in Vissim. I don't know if you can see those arrows. I changed the presentation type, and it seems to have made them partially invisible. So I'm saying that EOS is available if you have version 2024 from version Service Pack 8, which is already available. I think it was 2 or 3 weeks ago. You will have EOS available if you have the add-on. So it was officially released in Service Pack 7, but it was in German, so I recommend 8 or later. So if you have subscription or maintenance in the most modern version, that's the version that contains the EOS software that I'll be presenting today. So the first thing you see is in the type, right? You saw it in the last one, so that will be available in the dropdown from version Service Pack 8 or later. And then you'll also notice another button there. It's kind of grayed out at the moment. It says Web Front Panel, Open Web Front Panel. That button will become active when the Web Front Panel is accessible, and we'll discuss that a little bit more in a second. And then the update signal groups is something that's been utilized with other signal types in the past, but in the case of the EOS, it reads the configuration file from Syntrax and imports and updates the signal settings within Vissim to match what it needs to be in EOS to work. Adding the right detector and phase connections and pedestrian channels and stuff. And then you just need to match, you know, the crossbars and the phases in Vissim like you would any other signal type. So basically that update signals group kind of builds the connection between the Syntrax CFG file and Vissim to be logical to the program. And then if you don't want to always have to push that open web front panel, or you know you're always going to be working on a signal, let's say you're doing like a corridor study and you're always going to want to look at the signals every time you run it, you can click the automatically open web front panel during simulation. And that will open up the editor and the EOS panel every time you push play. So what does that look like? If you've never seen it before, which I would be surprised because it was the picture for advertising this, but when you do that, you get something that pops up like this. And the reason why I keep calling it a SaaS program is because, you know, it will pop up in a browser window, and using the more modern, the better as far as security and this and that. But all the features work in the applets within the browser. So all the buttons you can see up in the upper right hand corner of the EOS panel resemble that of the face of an EOS controller identically, and then you have the control interface LCD to the left, and then you have below that your phase and your channel, which you can watch actually moving in reality. This is a picture, of course, I'll show you in a minute. And then your coordination dial, which Dustin went over. What I've been alluding to this whole time is that the way that EOS has been implemented into Vissim in its current version is at 100 million mile upper level. It's similar to the event-based scripting engine in Vissim, so that it can maintain the speed and accuracy and clock between reality and the EOS controller. Think about it like you can't, if you go out in the field, you can't pause reality and check on the controller, right? It's always running in real time. However, Vissim is, it's not reality. So to bridge the gap, that's kind of how it was implemented into reality. So the simulation needs to be running in order to access the web front panel. This is a bit different from the things we've done in the past. You can see the diagram there to the right. Anyone who's done any of the scripting or looping within Vissim would recognize this, how between each time step, the information gets passed between the DLL to update the signal state. So that means when you pause the simulation, the signal state isn't updated and time pauses, so therefore the EOS panel pauses while it's running. So there are many different ways to work with that and kind of get used to, but it actually is implemented really well within the system. I think I'm going to take the chance to kind of just open Vissim. I've been talking a lot about it. Let me see. Tiffany, can you see the Vissim model now?
Yes.
Okay. Sorry, I'm screen sharing multiple presentations and multiple softwares and talking to myself, so I'm not quite sure. All right. So this is Service Pack 8, and this is the model I have here. So there's really no other functional difference between those that are like within the signal controllers. So you would come to the signal controller, and here I have a few set up. You can see now that EOS is a controller type. So if I were to create a new one, you can see that not only is it here now, but all the options within it are configured just to EOS. So here you have all these features now. And like I said, when you open up the editor, the open web front panel is locked. And that's because the simulation hasn't started yet. So basically, the controller exists in a void that doesn't, it's like being in nowhere land. No time exists, no reality exists. Until you introduce it, the simulation time, no time exists. However, here's your update signal groups. So I'll talk about that in a minute. So that's just the major configuration differences. So there's your automatically open. So if I want to click that, I can go okay. So then I'm going to slow this guy down a little bit so that we don't just blast right through everything. Okay, there we go. 2.0 real time. So since it's a signal controller type, if you've run a Vissim simulation, you've run a Vissim simulation, so you know what's going on. So I'm just going to push play and save my changes here. All right. Whoa, there we go. It opened way over there, but now we got it. Okay. So now you can see, which one did I do? Oh, let's do a more interesting one. Let's do this big intersection here. So you will notice here now when I right click here in the context editor, those options are also here. So I've got your open web front panel and show your signal timings table, and all this stuff is here. So obviously I can't update the controller configuration while the simulation is running. You know, now that's grayed out, but I can open the web front panel. So I'm going to go back, open up, and so if you've never seen a Econolite controller, welcome. I'm rather new myself, but the way that it works is the main menu is on an LCD here, and you interact with it, generally speaking, with these buttons. So if I were to want to look at the controller, let's say press 2, and I want to look at timing plan, I don't know, minimum green. I'm not going to change any of these things, but here you can see, and you would mouse around to the different things and change them. The controller is running, and if I understand correctly, and maybe one of you can ask Dustin at the end, but if you make changes, it would commit on the next cycle or something like that. But you know, this is what I mean about the simulation running the EOS panel software in a loop as if it's reality, let's say. Okay, so I can interact with the panel while the simulation is running as if I'm standing on the corner. So here you can see the channels, 7 and 4, green, yellow, red, and then the pedestrian channels over here. And the cool thing is you can manually trigger detector input to test different things. I'm not a real expert in there, but it is cool. And where is it? Sorry, let me reopen this. There you go. I've always been really fascinated with watching this run. Dustin alluded to this coordination dial here. So here it is running in the simulation. Phase 2 and 6, I believe, are the northbound and southbound directions. But I wouldn't bet my life savings on it. So it's kind of cool integration there, and you can actually, I believe, let me try this without making my entire computer explode. No, you can't do it all together, but you can open like this, I believe. So here you can see up at the top, all the different EOS IDs are from Vissim, and then the NTCAIP IDs from the signals themselves and from the ports. So you can check on all the, so this is kind of like monitoring. So if you wanted to, you could tile these all up and just kind of like monitor all the signals within the corridor, or do that kind of stuff, as well as you have your database and logs and stuff downloads as if you have the system as well. So super interesting. I'll show you a little bit more in the rest of my demo. Stop and don't explode, please. Okay, so let's go back to this guy here. One of the issues I ran into as a Vissim modeler with limited experience with Econolite technology, I'm being honest, you know, I don't know everything. So when I approached this for the first time, I didn't know exactly how to program this stuff. So I was introduced by a Econolite colleague to the ECU. I'm sure plenty of people who have Econolite signals know what this is. And basically, in the context of what we are doing in Vissim, we have been using this to edit the, access the web front panel and run simulations. Well, not simulate, well, simulations of the EOS controller that we're going to use in Vissim without running the Vissim simulation. So what that means is if I want to be like an engineer and I want to edit the CFG file for the Vissim that's already in there, but I don't want to run the Vissim file, I can access the CFG, the configuration file through this EOS controller utility, edit the timings, test them in the EOS controller, and then save them back to CFG and then run the Vissim simulation off, like, so doing the editing offline and then running the simulation. But since you save the CFG to the same file, then Vissim just picks it back up, not knowing that you've made the edit. So it's kind of like a little tool to go around the limitation of Vissim, which is that the simulation has to be running to provide context. So this ECU allows you that offline context for editing your signal file without using the Vissim instance. Another thing which I will not be presenting today because it's a customer feature. Lots of people who have Econolite tools, Centrax, Signals, ITS tools are familiar with the Centrax LE editor. One of my colleagues sent this picture to me of editing a project file, and here you can see the EOS editor on the right and then the configuration editor on the left. So if you have that and you know how to use that, you can also edit the timings and configuration files for EOS and then directly edit them, save them to the Vissim file all offline. Kind of cool little tools. So I'm going to do my best attempt at this as well as showing you this, as well as I have TSP written here. I'm going to show you that it exists, but I'm not the expert. So if you're interested in transit signal priority for Vissim and you're having issues with the RBC, there is quite an advanced signal priority algorithm within the EOS systems, and we can connect you with their Econolite people and talk more about that stuff. But I can also show in future webinars how this would work in this, and we haven't had a chance to get any test models or any project models yet, but it may be a good topic for a future PTV talks. So let me, oops, I didn't mean to make presentation go away, but that's fine. So here's that EOS, the EOS controller utility. Looks like this right here. So this is the file that I have from a different project. CFG files come straight out of Centrax, and then I'm sure there are other ways to make them through other programs, but these are the ones that were provided to me. And then if you, oh, it's already running, sorry. So I start that. Okay. So now you'll see that I have the exact same thing as before, same panel, but I cold started it through the configuration editor. So it's running the same simulation, except it's running it in its base configuration, i.e. it's just running the timing it's supposed to be without vehicular input. So it's not accessing the Vissim simulation. It's running a simulation of the controller. So down here you can test it by manually inputting vehicular detector data if you want to try to trip the detector, right? and try to access the minimum green. See, now it's registering a detector call in detector 2, and I don't know, come in and hit some of these until they've hit their call limits. If you want to, like I said, it's not simulating vehicles from Vissim. So if you want to try and overload one of the phases to test preemption outside of Vissim, these are kind of the ways that you would do it. So that's kind of a cool tool, and that's a free open source utility. I'm not like, I don't have any special Econolite licenses to use these tools. So if I were to go back into Vissim, so you can see here I already have these set up, and that's all. That creating a new file is difficult because when you add a new one and you make EOS, right, you can't immediately go in there. So that's why the context editors are good. You can come in here. When you try to edit as an EOS file, it doesn't really know what's going on. So generally speaking, it's great to start with the CFG files, but if you can't, then you just need to create an open one and then run the simulation. Yeah, so it's a much better idea to start with a CFG file if you can. So using one of those editor tools can give you the opening tools. But were I were to have something like that, I would just open something and let's say, um, let's just call that test. And see, no CFG file. So I'm just going to use one of my that I have right now. So if I have the CFG file, I can ask it to configure it based on Syntrax. So I have this update signal groups here. Go away. My apologies. So you have it here, update signal groups, or if you go here, edit, update signal groups. So if I click this button here, you can see 48 signal groups have been added. Okay, so I go back here, and in my test signal, I can see all these phases. So you see phase 1 through 16, those are the Econolite EOS phase channels that you saw in being displayed there in the web front panel. And then you have your pedestrian activation channels and your pedestrian detector channels, as well as if you're going to do preemption and as well as extension and check-in, check-out detectors. You have your overlap detectors as well. So overlap, pedestrian, and phase channels are all added. So now this is a working signal. So what you would have to do is the same stuff that you would do in any one, which is create the signal and then access it to this. So when you create the EOS signal in Vissim, it creates the controller in virtual space, but it's up to the user to connect the signal heads and the pedestrian phase heads and stuff to the Econolite signal, because unlike other signal types that might say, oh, no phases are connected to this, the Econolite controllers will run in virtual space forever. So make sure you connect the phase heads and the signal heads like any other signal type here afterwards. So here phase 1, phase 8. So that's here at this Sims and Towerton would be that phase 8, which in this specific signal is this one. So just assign those like normal. And if you don't know how to do that, I recommend accessing some of our previous trainings or previous PTV talks about signal setups. There are a few trainings that Levi's given about just both dynamic and fixed signalization. So a lot of those things can all be directly applied to the Econolite setup. So pretty much everything I've shown today has been in regards to setting up the controller. So if you have any issues with setting up the infrastructure, I recommend checking out our PTV Talks on ptv.to/learn. Yeah, so that is in the quickest way possible how we've implemented um, EOS into Vissim. So if you have further questions beyond that, I recommend getting in touch with me or Levi from the technical side of Vissim, or Dustin. Sorry, they're backwards. There we go. So Dustin would be your contact guy on the Econolite side. If you want to know more about how EOS works, um, how you can get controllers, if you already have them in your organization or within your agency, and you need to figure out how to access the data, you can reach out to the Econolite people. If you would like to know about how you can get it, the EOS in Vissim, feel free to reach out to me as well, so we can talk about technical implementations and technical training in Vissim in regards to signalization. So I'm guessing this next like 2 or 3 minutes, I'll pass it back to Tiffany. I don't know if there's any questions or anything else you need to pass on before we let everyone go.
No, I just wanted to say that this is the end of the session for today. Thank you everyone for attending. And a last reminder, we will provide a recording of this session and a follow-up email in the next coming days, so be on the lookout for that. And like Sean said, if you have any questions, feel free to email any of us, and have a great day. Thank you.
Thanks, Tiffany. See ya.